This is lesson 8.1, Theories of Acids and Bases. So the first definition of an acid and base was coined by Arrhenius, who said that an Arrhenius acid dissociates to form H+ ions, and an Arrhenius base dissociates to form OH- ions. Well, the problem with this definition is that it doesn't always fit all compounds. So Bronsted and Lowry came up with new definitions, where a Bronsted-Lowry acid donates H+ ions, which, if you think about it, when a hydrogen loses an electron, it's really just a proton, and a Bronsted-Lowry base accepts protons, or H+ ions. The conjugate pair is when you have an acid and a base that differ by one proton. So an acid that loses an H+ forms a conjugate base, and a base that gains an H+ forms a conjugate acid. So here's an example: acetic acid, CH3COOH. When you react it with water, the acid acts as an acid to donate an H+ to water, so it forms acetate, and the water accepts the H+ to form H3O+. So here you have the acid and its conjugate base, because if you were to go backwards in this reaction, the acetate would gain an H+ acting as a base. And here you have the water acting as a base and forming a conjugate acid, because if you were to go backwards, the H3O+ would act as an acid. An amphoteric substance is something that can act as both an acid and a base. So amphoteric substances have to have a lone pair of electrons and hydrogen that can be released by H+. So remember, in this example that we just had, the acetic acid was the acid and the water was the base, and the water accepted an H+, making it the base. In the next example, you have ammonia and water, and here you can see the ammonia is the base because it accepts the H+, and the H2O loses the H+ to form OH-. So here the water is an acid. So water can act as a base or an acid, and therefore it's called amphoteric. The last definition of acids and bases that you won't use as often are Lewis acids and bases. A Lewis acid accepts electron pairs, and a Lewis base donates electron pairs. So Lewis acid-base reactions form dative bonds, because remember, a dative bond is when both electrons come from the same thing. In this case, that thing is the base. So here we have BF3, and BF3, when you react it with fluoride, forms BF4. And the fluoride is donating 2 electrons to the boron to form a bond. So here the BF3 is the acid because it's accepting an electron pair, and the fluoride is the base because it's donating an electron pair. Another example is ammonia with H+ to form ammonium. The ammonia is donating an electron pair, so it's the Lewis base. The H+ is accepting the Lewis acid, or the electron pair. We saw this when we formed complex ions, or coordination compounds. The Lewis acids were always the metals, like copper, and the Lewis bases were the ligands, like water. So here, remember, you have copper, and the waters coordinate to them because the water has extra lone pairs on the oxygen that it can donate to the copper to fill those D subshells. And so here, the copper is the acid because it's accepting electron pairs, and the water is the base because it's donating electron pairs.